Hello everyone, my name is Onin Simon and I'll be presenting a presentation on a review on a paper titled Multilayer Perceptron Neural Network Approach for Optimizing Solar Irradiance Forecasting in Central Africa with Meteorological Insights. The paper is basically looking at how the MLP Perceptron Neural Network technique is applied to optimizing solar irradiance for forecasting for a data set that was specifically from Central Africa using meteorological insights, where we're looking at atmospheric pressure, temperature, wind speed, and others. So the contents of this presentation, we are going to look at the introduction, the problem statement, then also the keywords and the methods that was used, and then also discuss some of the findings. The researchers in this paper, they start by explaining how, due to civilization, there was a shift from the older ways of using biomass towards non-renewable resources, such as coal. However, they realized that over-dependence on such of some of these fossil fuels becomes a substantial challenge. And therefore, they realized that since relying on non-renewable fossils raises valuable concerns, they advocate for sustainable techniques. And to do these sustainable techniques, they want to come up with a way of forecasting the availability of some of these techniques now. They're using radiations, and with radiation, they're looking at energy from the sun and how they can predict the amount of the sunshine that will be available based on their model. Now, the problem they are trying to address here, they are saying that due to the over-reliance of their own on these finite fossil fuels, at the end of the day, they can be depleted. And we're looking at particularly in the region of Central Africa, where they found out that there is also existence of outdated energy infrastructure that limits economies, specifically Central Africa, from developing. Therefore, they realize that there's added need for solving this problem to advocate for renewable and sustainable resources. And with that, they came up with this research where the keywords within this research, they were looking at solar radiation, people neural networks, multilayer perception, and neural networks. With solar radiations, here they are looking at energy from the sun that is hitting the surface. So they're trying to find out energy from the sun hitting the surface, which is normally measured in watts per minute. And then that data they are capturing in that format is what they're using deep learning techniques, for example, feed-forward neural networks to come up with some sort of prediction. Now, with feed-forward neural networks here, they go ahead and review literature about experiments that have been done around it. And they explain it as one of the earlier techniques of deep learning that mainly talk about how information moves in one direction. So we feed forward, as it says, you feed in the inputs and they keep on going forward without that back and forth. And then they go ahead and talk about the multilayer perceptron. Now with the multilayer perceptron, for it also a type of diffusion neural network, which has one layer of inputs and then one or more layers of one or more hidden layers, and then also the output, and then the activation function. However, with the multilayer perceptrons, each input sends information to each of the neurons within or nodes within the hidden layers. So if you have an input, for each of those inputs, it will communicate with each of the other neurons and feed them information in that way. Then for neural networks generally, now this one's looking at a general computational model that's trying to imitate the structure of the brain, and communication is done to imitate how the brain operates. And the research incorporates some of these techniques. Now, the diagram here is looking at the feed-forward neural network, where we have our inputs on the left, and then we have our layers. And what we're looking at are the synaptic weights. Now, these are looking at the connections plus the weights of the what? The connections plus the weights of the inputs. So And then the transfer function, this is like a mathematical function that converts all the weighted outputs into some sort of one number, either a 1 or a 0. Actually, it combines all what comes from the inputs and comes up with a single output. Now, that output is what is taken into the activation function. Now, for the activation function, there are very many, there are a few kinds of activation functions that can be applied in the architecture. For example, softmax, ReLU. For example, in this study, they were using a sigmoid, logistic sigmoid for the activation, and then the output, which is at the end of the day, the predictions. So therefore, with feed-forward networks, what to note here is information moves in a single direction. Then we come to the artificial neural networks, which are inspired by the structure of and functioning of the human brain. Now here it has an input layer, then one or more hidden layers, and then the connections and weights, and then the activation functions before the output layer. Now the way this operates is when the inputs are added, the inputs, for example, for this case, we could have wind speed, humidity, or temperature that are fed in. Now, the weights and the connection are sent into the summing junction. Now, the summing junction for this case, it includes the bias, which is some sort of correction before moving on to the activation function that combines all the inputs into a single output. Now, when we go into details to look at the multilayer perceptron, now for this case, it has multiple layers of nodes, including an input layer and one more hidden layer. Now, the discrepancy here is that for any single input, it must communicate to each of other neurons within the other layers, as you can see. It's communicated to each of other layers before. Then also within the hidden layers, you can see also each neuron is communicating to each neuron within the next layer. Now, there are research gaps to note within this study, and also their study contributions. They looked at artificial neural networks as a technique for forecasting solar radiation. And then also they were using meteorological features such as temperature, wind velocity. We shall see how they were applied. Then the focus area was specifically in Douala, Cameroon, and the dataset was in a specific range from January 2019 to October 30th. They went ahead and used this methodology where they did pre-processing, processing, and post-processing, where the pre-processing was just basic data preparation, and then the splitting was done where 80% was used for training, 15% for validation, and 5% for testing. Then the post was actually evaluating the models. Now, this is the area where which is located where the data capture was done. As you can see on the right, that's the machine that was used for picking this data. Now they did that data analysis where for each of those inputs, they were analyzed against the month or time. As you can see, they started with temperature on the top left, and then wind speed top right. The bottom left, this was relative humidity, and on the bottom right was the atmospheric pressure. We can see atmospheric pressure within certain times was constant, and they explained how they moved some of the data that was not being used. For example, in the night hours, that data was eliminated. So when they went ahead and the actual framework that was used for this study was in this format. That's the architecture they used, the multi-perceptron, like I explained earlier above. And then this is how we are inputting the inputs. So I have the hour, day, temperature, and wind speed. So those were the inputs in the input layer. Then in the hidden layer, you can see the example, if hour is an input, it communicates with each neuron in the hidden layers before the solar radiance prediction is given. So when you go ahead, their results were printed out for each, where you can see this was temperature, atmospheric pressure, and then humidity. Then at the end of the day, when they combined all their results, these were their findings. where they got, on the training, they got an R2 score of 0.98, which was pretty well. Then the performance, the general performance, they realized that at the 50th epoch, that is when they got optimum performance. And epoch is just a complete cycle for each training of for each input neuron. Then the performance, as you can see, was found at the 45th epoch, and it was pretty much a better performance because it was, according to the study, they were saying it was at around 98%. Then other resources that were used as included above. Thank you for listening.